Hi, my name is John Paul Lambert from Benchmark PDM, Canada's national easy laser distributor. In this video, I'm going to show you the best belt alignment tool on the market. Now, we call it belt alignment, but we're not actually aligning the belts. We're aligning the shivs or the pulleys that the belts are attached to. Now, it is a well-known fact that the major cause of premature or early belt failure is due to pulley misalignment. Now, the tool that will guarantee you that this will not happen is the XT190 belt alignment tool. It is comprised of the laser transmitter and the digital detector. The laser transmitter generates a laser beam that is parallel to the reference shiv. The detector reads the position in relation to the plane and displays the values in angular and offset. To align belts and pulleys, we need to know three different measurements. The angular misalignment in the horizontal plane, so that's 3 o'clock to 9 o'clock. The angular misalignment in the vertical plane, so that's 12 o'clock to 6 o'clock, as well as the offset or parallel misalignment in the axial plane. To demonstrate how this laser alignment tool works, we will be using a simple demonstration stand with two shivs mounted. This side will be our stationary side as it's fixed, whereas this side will be our movable side, or maybe the motor, which would be sitting over here. We have little adjustment wheels so we can easily adjust to simulate a motor being moved. This, of course, does not demonstrate how the work is done in the field, but it will give you a good understanding of how the laser alignment tool works. We attach the laser transmitter to the stationary machine by clipping it on the side wall of the shiv with the magnetic pads. The laser beam, which is transmitted, is parallel to the shiv wall. The detector has 4 strong magnets that secure it to the shiv. We place this on the movable machine. It's a simple setup that fits on any size shiv. With both units on, you get an instant live-time reading of the misaligned results on the detector LED screen. This is a powerful option because you can very easily move your machine into alignment based on this live-time value. However, with the belt alignment program, we can more efficiently use this tool. I can use the program with the free XT alignment app on my phone. I can use it on a tablet. Or of course, I can use it on the XT11 display unit. The choice is up to me. For the purpose of this demo, I'm going to use the tablet so I can record the screen. When going into the belt alignment program, you can see right from the start that the alignment process is shown at the top of the screen with the icons. Currently, we are in the distances page where I can input the distance between the machine's feet, as well as some other certain data. The next icon shows the measurement icon. This is where I take my actual measurements. And finally, the documentation. That's where I can create a report. If I click the motor plus symbol, you can see that I can enter the shiv width, which will automatically compensate for me if I'm working with mismatched shivs. I can also add the shiv diameter, the tolerances, and the RPM. I will just put the most common RPM, which is 1725. To enter the distance between the machine's feet, I tap the area that says F1 to F2. F1 is the front foot, and F2 would be the back foot. There's actually not much adjustment on this demo rig. It is 2 inches, so I will just put 2 in and click close. Before I move on, I can tap the detector button to make sure I'm connected to the detector. And yes, it is connected. By tapping on the next measurement icon, you will see a lifetime result of the misalignment in a 3D image. I can move the screen around and look at it in a 3D image in different ways, but we prefer to use the grid view because it shows it in a nice way. Now we have the vertical plane on the left side of the screen, which shows the angular misalignment, as well as the shim that I need to correct at the bottom. So in the vertical plane, it's telling me I need to put 10 thou of shim, or 10 mils of shim, in the back end of the motor. On the right side of the screen, I have the same thing in the horizontal plane. The angular on the top right is 0.27 degrees, and below is the amount of adjustment I need to make. More closer to the middle, I have a 22 thou of offset, or 22 mils of offset, in the axial plane. To make the corrections, I'm going to start adjusting the angular misalignment. Now, I will start in the vertical plane as the process shows. And with that, I will start simulating putting 10 thou under the back end of the motor to lift it up. And by doing that, I will just turn the knob here. 10 thou. So you can see it come into alignment. So I put that 10 thou under the motor, I've lifted it up, and we're within spec in the vertical plane on the left side of your screen. Next, we correct the horizontal misalignment. So I will start pushing or pulling the motor so the sheave is in alignment. And you can see it come into adjustment there. And I would be happy with that. And finally, I will now adjust the offset along the shaft in the axial plane. And I would be happy with that at -1 thou. So at this point, I would be happy with all of my adjustments. I've corrected it. I would tighten down. I would remeasure just to make sure I'm getting repeatability. And after that, I would then go to my documentation screen, and you can see my logo, all the user information is in there. I have the vertical alignments, the horizontal numbers, the offset, and any notes or machine data that I've inserted.